Hey everybody, Mrs. Herman here. We are going to work on a 3-act task today called Tomato Tomato. Our question that we are trying to answer is how many little bottles of ketchup can fit inside the larger bottle of ketchup. So we're going to go ahead and watch this first video, and I want you to ask yourself or start thinking about some things things you notice. What do you notice about what's happening, and what do you wonder as you watch this video? Remember, our question is how many little ketchup bottles will it take to fill up the large bottle? As you're watching this video, keep in mind you are going to want to make a too high estimate and a too low estimate of the number of bottles that can fit in the larger one. So go ahead and check out Act 1. Okay, so go ahead and let me just kind of go here so you can look at that. All right, you are going to try and make an estimate. So what do you notice? What do you wonder? How many of those little ketchup bottles do you think could fit in the larger one? Go ahead and make an estimate that is too high and an estimate that is too low. So for sure you know there's got to be more bottles than this that fit in there, and for sure you know there's got to be less bottles than this fit in there. So go ahead and pause this video and take a second to do that. All right, the next thing is in Act 2, they're going to give us some more information. So let's click on this and let's see what they tell us. Okay, they tell us how many ounces are in each bottle and the number of grams in each bottle. So whenever I think of anything trying to fit into something else, I think division. So you can go ahead and choose ounces or grams. I'm going to go ahead and stick with grams, and I'm going to go from there, and I might need to adjust my estimate from there. So just based on this, if you guys see that the large one's almost 400 and the smaller one's around 60 grams, about how many 60-ish grams bottles can fit into a 400-ish gram bottle? And if you need to adjust your low estimate and high estimate, go ahead and do that based on this new information. Okay, from there, we're going to go ahead and hop into Notability with this information so we can actually try and figure it out. So how many little bottles of ketchup does it take to fill up the larger bottle of ketchup? So that picture from Act 2 told us that the larger bottle was 397 grams. There were 397 grams of ketchup. And the smaller bottle had 64 grams of ketchup. All right, and we said whenever we're trying to fit something inside of something else, we're thinking division. So we're going to need to divide these two numbers together. Okay, in order to set that up, I'm going to take my dividend, which is what I have, and I'm going to divide it into the size of the groups, which would be the size of the smaller bottles. That's going to be my divisor. Remember, when we're doing long division, some steps you can do are divide, multiply, subtract, bring down. Some people remember these steps by Dad, Mom, Sister, Brother, or Does McDonald's Sell Burgers? There's all different sayings that you can write down to help you remember the order in which you do division. So if we go ahead and get started, I'm going to ask myself, does 64 go into 3? No, it cannot. So I like to put a little X there to show that it can't fit into 3. Can 64 fit into 39? Again, no, it cannot. So I'm going to put an X above that. I need to figure out 64 can go into 397 how many times? So off to the side, I'm going to need to do some guessing to see how close I can get without going over. So if I do 64, if I just think even to, I always think in my mind, multiply by 10. I can do that in my head easily, 640. Well, that's way too big. If I were to cut 640 in half, I would be at 320, which is kind of getting close there. So 10 cut in half is 5. So if I did 64 times 5, I would get 320. So let's maybe try one above that and see where I'm at here. I'm at 384. So I know another 64 would put me over that 397 goal. So I'm going to say that it goes in 6 times. Okay, so that was my divide step. Now I'm going to multiply the 6 times the 64, and that was 384. I'm then going to subtract those values, and then I'm going to bring down. Well, in this case, it's the end of my number, so I don't need to bring down. If you want to calculate to the decimal, you can. But here, this is telling me that I'm going to have 6 full bottles of the little smaller ketchup bottles to fit in there. But this remainder is telling me I'm going to have to use a 7th bottle, and I'm going to use part of that. So when we do division, a lot of times when we can write our remainder, we can, write it as a fraction. So this 6 represents the whole bottles, and then I'm going to have 13 out of the 64 grams of the 7th bottle I'm going to need to use. So my final answer, I'm going to write it right up here, is 6 and 13 64ths bottles. So let's go ahead and watch Act 3 and see what happens here. I do know really quick that if I am dealing with 13 64ths, that's not even half. Half would be 32 out of 64. So this is fractions kind of around 1/4. So this is going to be about 6 and 1/4 bottles. So let's see if he fills in 6 full bottles and then another about 1/4 of a bottle and see if we were close. Okay, so let's go back. Act 3. You're going to see in this video, it says this little disclaimer here. If you guys have ever poured out ketchup, sometimes obviously there's some ketchup left in the bottle. So we want to make sure we're using all of the ketchup in the bottles. So they put colored water inside of those small bottles to simulate the ketchup so that all of the liquid is easily going into the larger bottle. Just so you wonder what's going on. Here we go. Okay, so they showed us in that last bottle. So there were 6 full bottles that were poured in, plus the last one was 2/10. Well, we know that 2/10 is very close. So that's like 20 hundredths. That's really close to 25 hundredths. So we got as precise as we could be with our division in order to figure that one out. So if we want to look, here's just a close-up of that, last bottle here. And you can see that there's definitely more than half the bottle that's still left in there. So awesome job, everybody. I'll see you here next time.